order to understand how the eye moves, let's first look at where it is located in the orbit. As you can see here, it is not in the center of the orbit. This means that the optical axis and the axis of the orbit diverge by about 45 degrees. This divergence is what causes the eye to move in three different directions: lateral and medial rotation, elevation and depression, or abduction and adduction. The muscles of the eye include the lateral rectus, which is innervated by cranial nerve 6. It originates at the common tendinous ring, and when it contracts, it moves the eye laterally. The medial rectus, which is innervated by cranial nerve 3, it also originates at the common tendinous ring, and when it contracts, it moves the eye medially. The superior rectus, which is innervated by cranial nerve 3, also originates at the common tendinous ring. However, it pulls along the axis of the orbit, which causes the eye to elevate, adduct, and medially rotate. The inferior rectus, which is also innervated by cranial nerve 3, begins at the common tendinous ring and also pulls along the axis of the orbit. This means that when the inferior rectus contracts, the eye adducts, depresses, and laterally rotates. The inferior oblique, which is innervated by cranial nerve 3, begins at the anterior portion of the orbit, and when it contracts, it abducts the eye, elevates, and laterally rotates. Additionally, the superior oblique, which is innervated by cranial nerve 4, begins at the common tendinous ring but travels through the trochlea, which causes the muscle to change direction, so that when it contracts, it abducts, depresses, and medially rotates. To clinically test the lateral and medial rectus, it's pretty straightforward. Have the patient look laterally in order to test the lateral rectus, and have the patient look medially in order to test the medial rectus. The other four are a little bit complicated. It's important to remember that muscles have the same movements, and in order to test them, they must be isolated from one another. For example, the superior rectus and the inferior oblique both elevate the eye. In order to isolate one from the other, the optical axis must be aligned with the direction the muscle is pulling. For the superior oblique, we have the patient look laterally so that the optical axis is in line with the axis of the orbit, which is the direction that the muscle pulls. Once the patient looks laterally, then we have them look superiorly in order to test the superior rectus. Similar thing for the inferior oblique. In order to test the inferior oblique, we have the patient look medially, which aligns the optical axis with the direction that the inferior oblique is pulling. So once the patient looks medially, then we have them look superiorly in order to test the inferior oblique. The same concept can be applied to the inferior rectus and the superior oblique, as we have them look laterally or medially before looking down.